A stunning burst of radio waves from a distant galaxy has set a new record as the most intense of its kind ever observed, and researchers have pinpointed its location with unmatched accuracy. On March 16, 2025, the CHIME radio telescope, situated in Canada, captured a singular fast radio burst, FRB, that was so powerful that astronomers were initially perplexed about its origins. This flash emitted, in just milliseconds, energy equivalent to what our sun produces over a span of 4 days. This extraordinary phenomenon has been dubbed the RBFLOAT, standing for Radio Brightest Flash of All Time. It's worth noting that these kinds of astronomical wonders are often misunderstood. The initial brightness of the burst led our detection systems to mistake it for radio frequency interference, which can easily stem from everyday sources, like cell phones or planes that are much closer to us. Explains Wen-Fai Fong, an astrophysicist at Northwestern University. Our team had to do some investigative work to confirm that it was indeed a genuine astrophysical signal. Fast radio bursts remain one of the universe's most fascinating enigmas. True to their name, these bursts are extremely brief, yet immensely powerful bursts of radio waves, seemingly erupting randomly from the depths of space. Generally, these bursts are categorized into two primary types: those that repeat, sometimes following a discernible pattern, and those that present only once, with no subsequent repeats from the same location. The advantage with repeating FRBs is that they can be anticipated and tracked with relative ease due to their predictable nature. In contrast, one-off FRBs are inherently unpredictable and possess a fleeting duration shorter than a blink of the eye, making them notoriously challenging to trace back to their source galaxy. To address the difficulties in tracking these transient phenomena, CHIME has enhanced its capabilities by adding smaller secondary telescopes known as outriggers, which are installed far from the main facility in Canada. These additional detectors have equipped researchers with the necessary tools to accurately triangulate the signal down to a resolution of just 45 light-years. Thanks to the full array of outriggers, a research team succeeded in tracing RBFLOAT, which humorously has also been referred to as root beer float, a name that brings some levity to the scientific pursuit, to the outskirts of a galaxy located in the Big Dipper constellation, roughly 130 million light-years away. This discovery marks it as the closest known non-repeating FRB to date. The pinpoint accuracy achieved in localizing this event allowed scientists to closely examine the environment from which the FRB originated, utilizing advanced equipment at the MMT telescope and the Keck Observatory for detailed follow-up studies. Such observations are pivotal in narrowing down the potential objects responsible for emitting FRBs. A considerable array of evidence now suggests that highly magnetic neutron stars, known as magnetars, might be responsible for a significant portion of the FRBs detected from Earth. Yushin Vic Dong, an astronomer at Northwestern University, notes the FRB is situated on a spiral arm of its host galaxy. Spiral arms are usually bustling with star formation, lending support to the hypothesis that it originated from a magnetar. Our sensitive imaging from MMT allowed us to zoom in and discover that the FRB is actually located outside the nearest cluster of star formation. This positioning raises intriguing questions. Could the magnetar have been ejected from its birthplace, or was it formed at the FRB site, separate from the center of the star-forming cluster? An additional investigation of the location, conducted with the James Webb Space Telescope, reinforces this interpretation, further elaborating on this exciting cosmic odyssey. The significance of RBFLOAT cannot be overstated. This extraordinary event, with its remarkable brightness and relative proximity to Earth, could provide valuable insights into the nature of FRBs. Presently, astronomers are actively engaged in determining whether there are notable differences between repeating and one-off FRBs, and whether magnetars are the sole creators of these bursts. Analyzing individual FRBs is crucial to addressing these complex inquiries. However, RBFLOAT is just one instance in the vast cosmic sea. Its detection exemplifies how CHIME has revolutionized our ability to uncover other similar phenomena. With the help of the CHIME outriggers, we're embarking on a new chapter in FRB research, states Taraneh Eftekhari from Northwestern University. We anticipate observing hundreds of precisely localized events in the coming years, which will allow us to gain a broader understanding of the varied environments from which these mysterious signals arise, bringing us closer to deciphering their secrets. RBFLOAT is simply the beginning of an exciting journey. This groundbreaking research has been documented in the Astrophysical Journal Letters.